Hello, everyone, and welcome to this explainer on behalf of Forge College. I am so excited to be with you today. Okay, so if you've been following along with our journey from EVM to SVM, you know we've been deep in the trenches, right? We've wrestled with Rust's borrow checker, we've wrapped our heads around Anchor's context, and we've been furiously sketching out these guided translations of core patterns. And honestly, we made some incredible progress in that last module. But right now, all we have are essentially a bunch of really smart napkin scribbles. Today, we're taking those scribbles and we are turning them into formal, official engineering patents. We're going to lock in those design decisions so that anyone, anywhere, can read your blueprints and understand exactly how and why you built your code the way you did.
Here's our quick blueprint for today's explainer. 1. Welcome to the catalog. 2. Anatomy of an entry. 3. The drafting process. 4. The access pattern example. 5. Peer review and checklists. And finally, 6. Publishing your milestone. Let's dive right in.
Welcome to the engineering blueprint phase. Now, for today, consider me your slightly exasperated but always friendly chief engineer. And I really have to remind you of the golden rule of engineering. A blueprint isn't actually a blueprint unless someone else can read it. Your code might be absolutely brilliant. It might compile perfectly on Solana, and it might even save gas. But if the next developer who inherits your smart contract can't figure out why you structured your Anchor accounts a certain way, yeah, they are going to rewrite it from scratch out of pure spite. So this phase is where we finally bring order to the chaos. Section 1. Welcome to the catalog. From scribbles to specs. So our working definition here is pretty simple. A catalog entry is a formalized, review-ready engineering document. It meticulously details your code pattern's translation intent, the rationale behind your choices, and the design trade-offs you had to make. Think of this as your formal patent application. You know, in the Web3 space, we don't just want to know that your code miraculously works. We want a searchable, robust repository of knowledge. This catalog entry literally bridges the gap from simple inline code comments that, let's face it, just get lost in the noise, to a comprehensive architectural document that will actually stand the test of time. Now, the core tension every single developer faces when moving from Ethereum to Solana rests between two poles. On one hand, you have fidelity, right? Like how faithfully did you recreate the original Solidity semantics line by line? On the other hand, you have idiomatic. How well did you embrace Anchor's explicit account-first model? Let's say you're translating a Solidity mapping. Do you just try to force a giant monolithic state structure to mimic the EVM, prioritizing fidelity? Or do you splinter that state into individual program-derived addresses like a proper Solana developer, prioritizing idiomatic architecture? You almost never get to have 100% of both. It's basically impossible. This delicate balancing act is the absolute beating heart of your documentation. The rationale in every single catalog entry must explicitly document this trade-off. Section 2. Anatomy of an entry. The required fields. Okay, so we have strict metadata fields required for every single entry. You need a unique pattern ID, a clear title, and a category tag pulled directly from our taxonomy. Things like access control or state management. Then you must include a Solidity snippet and a Rust Anchor snippet. These should be presented side by side and kept under 60 lines so they actually remain digestible. And finally, the heavy hitters, the rationale and comparative notes. I absolutely cannot stress this enough. This strict formatting is exactly what makes the catalog searchable and maintainable. If we all just wrote free-form essays, finding the right access control patterns 6 months from now would be completely impossible. Beyond the metadata, the actual written content of your entry rests on 3 content pillars. First, the intent statement, just a short paragraph explaining the pattern's overarching purpose. Second, the rationale. This is your deep dive into those fidelity versus idiomatic trade-offs we just talked about. And third, the comparative notes. This is where you outline alternative approaches you considered but ultimately rejected. Saving a future developer from spending 3 days going down a dead-end architecture you already tested, that is literally the greatest gift you can give them. A great engineering entry doesn't just show the what, it meticulously explains the why. Honestly, if you aren't explaining why you rejected an alternative, you simply haven't finished your blueprint. Section 3. The drafting process. Building the blueprint. To build your documentation efficiently, you'll want to follow this 5-step assembly line. Step 1. Normalize your metadata so everything aligns with our taxonomy. Step 2. Extract those side-by-side code snippets from your previous exercises. Step 3. Expand your terse inline annotations into structured, well-written rationale paragraphs. Step 4. Write out those comparative notes. And Step 5. Submit it for peer review.
I highly recommend working in small batches of 1 to 3 entries at a time. It treats your documentation like a rigorous, iterative build loop, rather than some massive essay you frantically leave until the night before it's due. Section 4. Example. The access pattern. Putting it into practice. Take a look at the classic Solidity snippet, the only owner modifier. It relies on a require statement checking if msg.sender equals the owner. This is an implicit check happening right in the middle of your execution flow. Now compare that to the translated anchor version. It doesn't use a handler function check at all. Instead, it uses an explicit account constraint, pub struct owner only, strictly requiring the owner to be a signer.
So when you write the rationale for this catalog entry, this centralized validation is exactly what you need to communicate. You must justify why you abandoned the direct line-by-line fidelity of the Solidity require statement in favor of Anchor's explicit account-first model. The core rationale is that Anchor centralizes validation. By enforcing the constraint in the account struct, the check executes at the runtime boundary before the handler logic even fires. This completely eliminates a whole class of manual errors, it avoids wasting compute units on invalid transactions, and it drastically improves overall safety. This is the exact kind of robust defense you need to write in your entry. Section 5. Peer review and checklists. Defending the design.
I want you to burn this ultimate question into your memory. If I had to translate this pattern under a different constraint, which alternative would I choose and why? This is what every single peer reviewer must ask when evaluating your comparative notes. If a reviewer reads your documentation and cannot confidently answer this question, well then your comparative notes are not finished. You need to go back and elaborate on the rejected alternatives.
To ensure your blueprint actually survives the review board, here are the hurdles your entry must clear. First, clarity. Are you avoiding unexpanded jargons so an EVM developer can actually understand it? Second, reproducibility. Can I trace exactly how you got from Solidity to Anchor? Third, correctness. Is your Rust code actually syntactically plausible, or did you just hallucinate some brackets after staring at your monitor for 14 hours? And finally, peer sign-off. You need a colleague to officially stamp it for approval. Coffee bribes are entirely optional here, but highly recommended. The point is, your code must be completely defendable. Section 6. Publishing your milestone. The finish line. For this specific capstone milestone, your magic number is 6. You're required to produce at least 6 perfectly formatted, peer-reviewed, and accepted catalog entries. These 6 entries need to clear the clarity and correctness checkpoints, they must address both the intent and rationale pillars, and they have to be completely ready to be merged into the canonical repository. This, right here, is your proof of mastery. I'll leave you with this final provocative thought. Will your rationale stand the test of time? Think about it. 6 months from now, when the context is gone, the tickets are closed, and literally only the code remains, will your blueprint save the day for a future developer? That is the exact standard we are striving for here. Remember, precision in your documentation is just as absolutely crucial as precision in your logic. Thank you so much for joining me on this explainer brought to you by Forge College. If you want to dive deeper into this capstone module, explore more translations, or access an entire library of Web3 resources, please visit forge.college. Keep building, keep documenting, and I will see you in the next one.